Hi everyone, I'm Cal Shepherd, the Data Jiu-Jitsu guy, and today I'm going to talk to you about the data lake. Before we get into the content, I thought it'd be worth giving you a quick introduction. I have over 15 years experience within the data industry. I started out as a business intelligence developer, and I've worked in a variety of different data roles, and I currently work as a data architect. This video is part two of a four-part series where I discuss the journey the data industry has been on over the last 20 years. This series is aimed at anyone with an interest in data, and I will aim to keep it as simple as possible so that everyone can understand. Data is becoming an increasingly essential topic for everyone to understand and is no longer just for data professionals. So firstly, I'd like to take you through the agenda. So to begin with, I'll take you through what a data lake actually is, and then I'll discuss why you would actually want to use one. Then we're going to discuss some comparisons between the data warehouse and data lake. Then I'll give you a example of how this actually works in reality. And then finally, we'll go through a summary and discuss next steps. So first of all, what is a data lake? Again, if you type in what is a data lake on Google, you're going to get a lot of different descriptions of what it is. But I think this one that AWS provide is quite a simple one. So a data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. You can store your data as is without having to first structure the data and run different types of analytics from dashboards and visualizations to big data processing, real-time analytics, and machine learning to guide better decisions. Now, for those of you that are more visual learners, this is quite a nice diagram that was provided by Microsoft, just to show you. As you can see, you've got the data lake at the bottom here, and all these arrows are indicating is that pretty much any data set that you can think of can essentially be dumped into a data lake without having to worry too much about transformations. I'll take you through this in more detail when we go through the examples. So if you'd like to go into a bit more of a technical deep dive, there isn't any books I would necessarily recommend. I'm sure there are some good ones out there that discuss the data lake, but I think you can get a lot of really good information with some of the big vendors out there. So Microsoft has got a section on data lakes. Amazon, AWS has got exactly the same sort of thing, and then Databricks, which is another big vendor out there, has got a good introduction to data lakes. So why would you actually want to use a data lake? So one thing that the data lake is really good at is it grants users quicker access to the data due to the ease of storing. Data warehouses require transformations before loading the data in, whereas with a data lake, you can just store the data as is. Another great thing about a data lake is that it scales to hold any amount of data at a very low cost due to the type of storage used. Data warehouses, because they are databases essentially, they can be expensive to store big data. Big data is a buzzword you might hear when you're looking at things like data, into things like data lake. The third point is that it allows you to collect all data just in case. When you're looking at building a data warehouse, you would typically only bring in the data that you think is relevant. Whereas with a data lake, you can actually collect everything just in case. And then it might be that there's a particular field that you didn't think you would need from a data warehouse point of view, but because it's in the data lake, you've already got access to it. Now, one thing that I've seen work really well with data lakes is that it allows you to explore the data to see what is actually valuable. And the way I've seen it work in the past is that you can, as we've said, you can collect all the data just in case and store whatever you like. And this can then act as a requirements gathering exercise for the data warehouse. So you might explore some of the data sets that you've put into the data lake and then realize that you'd like to bring that into the data warehouse as well. It's also quicker to ingest and exploit large amounts of data. I'm not going to go too much into the detail because it can get quite technical, but just know that it's much quicker to ingest and exploit. It also provides you with flexibility to store the data in an open format. And this final point, which I've put in bold, is that a data lake does not replace a data warehouse, but it's to be used in conjunction. So just to give you this next one is titled data warehouse versus the data lake, and this is just going to give you a comparison between the two tools. So I think this can be, there is a bit of these lines can be quite blurred, but at the same time, I think this gives you a nice description of where you might use a data warehouse and then where you might use a data lake. So firstly, on the data warehouse side of things, you would generally use a data warehouse for descriptive analytics or diagnostic analytics. So descriptive analytics, that's looking at what's happened. So that might be something like sales for last year, for instance. And then for diagnostic purposes, that's looking at why did it actually happen. So that might, getting a bit more into the detail of what other things may have caused your sales to be lower than they were the previous year or something like that. Now, with a data lake, you're generally using that for predictive or prescriptive analytics. Now, what we mean by that is from predictive side of things, that is what might happen. So that might be, predicting sales for the next 12 months. And then prescriptive is then almost taking that one step further, is that you might be predicting sales over the next 12 months, but then you would actually prescribe what action should be taken off the back of that. So just some very general terms and things you can think about with regards to a data warehouse and a data lake is that data warehouses are slower to build and maintain due to the enforced structure and transformation that's required. Another thing with a data lake is that because it's so easy to actually load the data in there, they can quite often become what people refer to as a data swamp. And particularly in the early days, this quite often happened where people would just store data, whatever data they could think of in the data lake, but then nobody really knew where to go for certain types of data because it just was not structured in the right way. Another good way to think about it is that a data warehouse is generally top down and a data lake is more bottom up. And what I mean by that is that with a data warehouse, you would quite often know upfront what it is you are trying to achieve, and therefore you can build all your transformations and model your data in the way that to suit those particular use cases. Whereas with a data lake, you don't often know what it is you are trying to achieve, which is why it's more bottom up, because you can store all the data that you think might be useful, and then from there you can, like I said, build your predictive and your prescriptive analytics off the top of that. And what quite often happened, particularly in the early days, is that you would have copies of data, so the same data in the data lake and the data warehouse, because it's going to be used for different use cases a lot of the time. And in the initial, when the data lake first came into prominence, there was a lot of hype around it, and a lot of people would say things like the data warehouse is dead, which in reality isn't true, and both are needed depending on the particular use cases. And again, I think it's worth highlighting here when the data lake first came out. Initially, there was a very clear differentiation between the two tools, but those lines have really started to blur now, which is a positive step, and we'll hear more about that in parts 3 and part 4. So, how does this actually work in reality? So, this is deliberately a very simplified example, but I thought it'd be worth taking you through a typical process. So, a business decides that they'd like to invest in a data lake to help them get access to data and make better decisions faster. A data scientist or a data engineer works with a business to define a particular problem and then figure out what data is required to solve it. Data could be stored in a variety of different ways, but for simplicity, let's assume the data is in an OLTP database, which is what we talked about in the previous video. A data engineer then works with a data scientist and extracts the data required and loads it to the data lake in a raw format. This is quite often referred to as ELT, so extract, load, and transform. And if you remember from the data warehouse video, this is slightly different and it's ETL processes as opposed to ELT. So that's one of the major differences is that with a data warehouse, you would perform extract, transform, and then load. Whereas with a data lake, it's quite often you would extract, load, and then transform the data. And then once built, the data engineer may need to maintain these ELT process on a schedule. And then finally, the data scientist uses the data lake to perform some form of predictive or prescriptive analytics. So I thought it'd be worth using an airline again to bring this example to life. So first of all, you've got the decision. So a decision is made that the business would like to create a data lake, and their priority is to forecast ticket sales over the next 12 months for workforce and financial planning. The next stage is development. The data engineers develop the appropriate ELT processes to land the data required for forecasting into the data lake. The next step is where the data science takes place. So the data scientist analyzes the data and builds a ticket sales forecasting model to predict sales over the next 12 months. And then the next step is where the insight is gathered. And upon analyzing the forecast data, you notice that you're understaffed in certain areas to keep up with predicted demand, and your revenue is also expected to be higher than anticipated. And then your final step is your action. So the ticket sales forecasts are distributed to the appropriate stakeholders, and decisions can be made as to whether to recruit new staff due to the increased revenue and demand. So just to summarize, data lakes are another fantastic tool that arose to prominence due to some of the limitations of a data warehouse for certain analytical use cases. I hope that I've been able to convince you that there is real value in both the data warehouse and the data lake. And the real power is when you use them together and select the appropriate tool for the right use case. Part 3 in this series and the next step on the journey, we will cover the modern data warehouse, which is the first step to try and bridge the gap between the data lake and the data warehouse and have a single approach for all analytical use cases. So thank you for listening. If you enjoyed this video, then please like and subscribe to my channel. And if you've got any questions or comments, then feel free to add them to the comments section. Thank you very much.